In this lecture, we are going to look into the connection mode of the Bluetooth protocol. So connection mode in Bluetooth is used to support bidirectional communication between two devices. And this mode supports much higher data rate than the advertising mode. And it also allows for much better quality of service. A good example of an application where you would want to use a connection mode is, for example, when you want to stream audio. If your Bluetooth earphone connects to a smartphone, you would want to establish a connection to ensure that the audio is received from your smartphone to your earphone without any lags and with a very high quality. So typically, if you look back at the topology of a Bluetooth network, in a peripheral device or an end device could either be in a connection mode or advertising mode, and the central node could be either looking for advertisement, or it could be in a mode where it has established connection with another device. And one thing that we should keep in mind is that when a connection is established between two devices, both of these devices act like a server. That means both of them can read or write fields that on the other device. That means both of them can be exchanging data bidirectionally. So here we look at for a typical timeline for a Bluetooth connection. So a host basically starts, let's say the host P is the advertising node. It starts and it sends the advertising channel on the advertising packet on the 3 channels. And the host A is in the scanner mode. That means it is looking for these advertising packets. Now, as soon as the host A receives these advertising packets, and then the advertising node sends another packet, then it sort of like sends a request that I want to establish a connection. And then once the connection has been established, then the data exchange, or bidirectional data exchange, can happen between the host A and host B. So as you can see that the establishment of the connection mode actually starts with the exchanging of advertisement packets. And once these advertising packets have been used to discover the other node, a connection is established between these two devices. So once the connection is established, typically the medium access control mechanism that is used is based on time division multiple access. And one thing to keep in mind is that only the central node needs to know the schedule of the for the TDMA mechanism. And the central node controls the interaction with the peripherals that are connected to it. And typically it's the anchor point and the connection interval that it determines a schedule for a specific device. So we show one such example on the slide. So how do the central node manage synchronization with the end devices? So the central node sends first packet at each connection interval, and on each received packet, this resynchronization can occur. So how many peripheral devices can be supported? We can theoretically support thousands of peripheral devices connected to one central node. So we talk about this calculation with the example on the slide, but typically what happens is that in the real world, this number is far lower. So typically, if you look at your Android or a iPhone, it sets a lower limit of 4 to 15 devices that can be connected to the phone. Or another chipset, for example, NRF52 is one of the popular radio chipsets, and it allows you to support up to 20 such end devices. And the reason for this constraint is because of the limits that are imposed by the memory and the complexity of the implementation of the Bluetooth stack implementation. So what would be the maximum throughput that can be supported? At the file layer, it supports a maximum throughput of about 1 megabits per second. However, the packet overhead and the timing delays would make the real throughput that is achievable by an application using Bluetooth to be much, much lower than this. So next, let's talk about something called GATT. It stands for Generic Attribute Profile, and it is used to facilitate discovery, reading, and writing of data between two devices that have established the connection. And GATT is typically designed around the concept of profiles, services, and characteristics. So what are profiles? A profile is a collection of services that define a particular use case or a device behavior. For example, a heart rate monitor profile might include services related to measuring of the heart rate and sending notification. Next, a service. A service is a collection of characteristics that are grouped together to fulfill a specific function or feature of a device. And services are identified by something called unique UUID, which stands for Universal Unique Identifier. For instance, a heart rate service would contain characteristics for the heart rate measurement, sensor location, and, for example, control points. Now, characteristics is the smallest unit of data in GATT, and it represents a specific data item or value, such as sensor reading or a device setting. And each characteristics has a unique UUID and properties such as read, write, notify, and value. In the case of a heart rate monitor, a characteristics might represent the current heart rate from the measurement in beats per minute. So GATT is organized in this way from profile, which contains services, which contains characteristics. And when two Bluetooth devices connect, they use GATT to discover each other's services and characteristics. And the device acting as GATT server stores the data and provides it to the GATT client, which requests or receives this particular data. So as we have briefly mentioned, so how is these discovered? So there is a discovery phase when the connection has established first, where this information about what are the services and characteristics is shared between these two devices. So this talks about the connection mode for Bluetooth. Next, we actually briefly just look at the Bluetooth's emerging standard, which is called Bluetooth 5. And you are going to see more and more devices use this particular standard in the real world. And this standard introduces a number of major changes. For example, it supports multiple different physical layers. It has an advertising extension that allows you to send a lot of data. And it also has, as we had discussed in the previous lecture, that it supports localization using angle of arrival. It also has several other minor changes, which we are not going to talk about. So if you look at, for example, the physical layer, it now supports much higher data rate. So the base bit rate for the physical layer has been improved to 2 megabits per second, and it allows you to transmit more data within the same time period. In addition, it has also introduced something called coded 5, where it has introduced a forward error correction and a spreading mechanism that allows you to achieve much higher transmission range and reliability compared to the classical Bluetooth. And because of this coding, the data rate goes down to about 500 kilobits and 125 kilobits, but you are able to get much higher communication range because of the benefits of the coding. So typically the way it works is that when the two devices connect, after connection, they can switch to one of these new 5-layer modes after performing connection. And advertisement can use with these extensions only. So how does the revised processing pipeline look like? For example, now you perform, after performing the whitening task, you perform this forward error correction coding, and then you map it to split the bits, and then you wirelessly transmit it. And at the receiving side, you perform these reverse operations. So first you do the pattern mapping, and then you perform the decoding of the forward error correction processing that you have performed. You de-whiten it, and then you perform the rest of the steps. So you have now 2 additional steps compared to the Bluetooth standard 4.2 that are part of the processing path. So let's talk about extended advertising. One of the major changes to the Bluetooth 5 standard is the introduction of extended advertising mode. And this mode allows sending of very large payloads. And this becomes more important because we now have IoT devices that have more sophisticated sensors, such as an image sensor, which would require you to send a lot of information. And it is particularly useful for modern applications that require you to send a significant amount of data to the other devices. So extended advertising allows for large advertising payload up to 1650 bytes. Just compare it to, for example, 31 byte of application payload that was possible in the previous version of the Bluetooth standard. And this enables devices to share more information and can also reduce the connection time and improve the overall user experience. So the way this mode works is that the packets are sent in the regular advertising channel, which then point to an extended data transmission that is happening over the data channels. And hence, in some respect, you can think of that these advertising packets sort of point towards the further data transmission occurring on the data channels. And there are several benefits to having sort of like a division like this, that it reduces the collision on the normal advertising channels, and as well as sort of like allows you to have higher resilience for sending large amounts of data by using data channel and frequency hopping on these particular data channels. So it also allows you to reduce packet collision. So in general, extended advertising is something that can allow you to send large data with the better reliability compared to the classical Bluetooth. So how does the scanning occur for the scanner device that is going to receive these extended advertisement? The scanner node scans for transmission on the 3 primary advertising channel, similar to how it happens in Bluetooth 4.2. However, next, when it receives this special advertising packet called ADVEXTIND, it sort of like changes to the secondary or the data channel on which the information is being sent. And it then scans and receives from the specific data channel at a given time when the transmission is occurring. So thank you very much. With this, we come to an end of this particular part of the lecture.